Okay, let's jump right in. Welcome to this explainer. Today, we're diving into an absolutely incredible cosmic mystery, focusing on Caldwell 46, which you might also know as Hubble's Variable Nebula. We're looking at one of the most fascinating optical illusions in the night sky. I mean, we are talking about a massive, glowing celestial object that appears to just completely defy the laws of physics right before our very eyes. It morphs and changes in ways that frankly just shouldn't be possible for something so unimaginably huge. So here is the brilliant question, and really the core anomaly we're going to explore today. How does a massive nebula completely change its shape in just a few months? Think about it for a second. Nothing with mass can travel faster than the speed of light, right? Yet astronomers have literally watched structural changes ripple across this nebula in a matter of mere months. We're talking about changes covering distances so vast that for the gas to actually be moving, it would require matter to travel at impossible, physics-breaking speeds. So how on earth is a structure light years across visibly morphing so rapidly? Just to set the scale for what we're looking at, this captivating object is located a staggering 2,500 light-years away from us, over in the Monocerotis constellation. To put that into perspective, the light reaching our telescopes right this second, it left Caldwell 46 around the time the ancient Greeks were building the Parthenon. But despite this massive distance, the changes in the nebula are distinct enough to be seen right here from Earth, which honestly makes solving this mystery even more crucial. Now, Caldwell 46 is officially classified as a cometary nebula. And when you look at it, it really does look like a giant cosmic comet streaking through the dark. But actually, scratch that, it has absolutely nothing to do with actual comets. It's really a massive, sweeping cloud of interstellar dust and gas, brightly lit up by a brilliantly active but heavily obscured star hidden right at its tip or apex. Section 1. The Historical Detectives, a Century of Observations. Let's see how astronomers have tracked this over time. Understanding Caldwell 46 hasn't exactly been an overnight process. It's been a century-long detective job. William Herschel first spotted the nebula way back in 1783. Then, by 1861, an astronomer named Schmidt noticed that the star at its core was kind of varying in brightness. But the real breakthrough? That came in 1916, when a young Edwin Hubble confirmed that the nebula itself was actually changing shape. This sparked an absolute obsession for astronomer C.O. Lampland. He spent the next 35 years diligently collecting 940 photographic plates of the nebula just to map out every single shift in shimmer. So the absolutely crucial point realized from Lampland's massive collection of plates was that the nebula wasn't just sitting there glowing steadily. It was actively and almost violently fluctuating. The entire structure would dim, shift, and sometimes totally obliterate its own visible details. It was as if this permanent framework was there, and these intense waves of luminosity and dark obscuration were just sweeping right over it. Section 2. The Star Behind the Curtain, Piercing the Dust. Time to reveal our primary suspect. To truly understand this celestial crime scene, we have to lift the veil. Modern high-resolution infrared imaging finally pierces through all that thick dust, and it reveals the engine driving this whole thing, our Monocerotis. It's a massive, incredibly young and volatile Herbig AOB-type star. And surprisingly, it isn't alone. It's actually a binary system with a smaller companion star, R-Mon-B, nestled right nearby and surrounded by incredibly dense spurs of material. In normal visible light, this star is totally hidden, but adaptive optics show us exactly what's hiding at the tip of the nebula. This hidden star is the cosmic engine driving everything we see in Caldwell 46. Our Monocerotis is surrounded by a thick, dusty accretion disk. It's actively pulling in material and, at the exact same time, firing off high-velocity, collimated jets of gas moving at a blistering 100 kilometers per second. So as you can imagine, it is a wildly chaotic, violent environment. And just look at how bizarre that environment gets. What we're seeing here traces twisted double-helix magnetic filaments running along the eastern edge of the nebula, based on those infrared observations. It literally looks like a giant cosmic strand of DNA. These twisted filaments give us a huge hint about the intense, twisting magnetic fields and chaotic forces at play deep inside the nebula's core. Section 3. Ripples on a Big Screen, Solving the Mystery. Let's break down how this grand illusion actually works.
So we've got our hyperactive young star and a very dusty environment. Now, let's solve the mystery of those impossible speeds. A really fascinating 2025 paper by Lightfoot and Schultz beautifully explains this phenomenon. They call it the shadow theater effect, and it breaks down into 3 simple dynamic steps. First, our young star emits an intense beam of light. Second, dense, relatively small clumps of dust orbit very closely around that star. And third, as those clumps pass in front of the star's light, they cast massive, fast-moving shadows out onto the wider dust shell of the nebula.
The most important takeaway here is that we aren't actually seeing a massive gas cloud physically moving at impossible speeds. That was the illusion. Instead, the nebula itself, that huge fan shape, is basically a stationary, hollow, parabolic cone of dust. It's acting precisely like a gigantic, static movie screen. We basically caught the universe putting on an elaborate shadow puppet show. Think about the sheer scale contrast for a second. You have dense little clumps of dust, maybe just the size of our own solar system, orbiting rapidly right next to the star. As they move, they block the light, casting fast-moving shadows across a screen that is thousands of astronomical units wide. Because the screen is so huge and so far away from the light source, a tiny, slow movement of dust near the star translates into a massive, seemingly faster-than-light sweep of a shadow across the outer nebula. These ripples are cast across a 15-degree latitude band on the nebula's surface, completely tricking our eyes into thinking the nebula itself is shape-shifting.
This modern conclusion perfectly wraps up the century-old mystery that puzzled Hubble and Lampland. By proving we're simply watching light ripples traversing a vast cosmic canvas, we realize that Hubble's variable nebula is quite literally the universe's grandest shadow puppet show.
It really leaves you marveling at the mechanics of the cosmos, doesn't it? Looking deep into the past at Caldwell 46 gives us this real-time shadow play, perfectly explained by geometry and light. But it definitely makes you wonder, if an entire shape-shifting nebula is just an illusion of shadows, what other profound, physics-defying cosmic mysteries are out there, just waiting for us to find the right perspective to solve them? Thanks so much for joining me on this explainer, and as always, keep looking up.